Welcome to the April issue of the LHC News. Today, April 16, 2009, marks an important milestone in the LHC magnet repair process. In just a few seconds, through this shaft, the last dipole of the 39 damaged by the incident of September 19th is going to be lowered into the LHC tunnel to reach its final destination in sector 3-4. But before this complex transport operation starts, let's take a closer look at the magnet itself. And here is a dipole magnet, 15 meters and 30 tons of highly sophisticated technology. There's 1,232 of them in the LHC machine. For that, this is the most important and most conspicuous component of the 27 kilometers ring. Dipole magnets are used into the LHC to keep the 7 tera-electron-volt proton beams in their circular orbit all along the 27-kilometer ring. To be able to do this, these dipoles have to provide the highest magnetic field ever generated by a particle accelerator magnet, 8.3 Tesla. An electrical current of 11,700 amps, about 1,000 times more than most domestic appliances, flows inside the dipoles to generate this extremely high magnetic field. And this is only possible by cooling the magnets at a temperature of 1.9 Kelvin, that is minus 271.3 Celsius, by injecting superfluid helium into the whole circuit. Let's now hear from Hervé Prin, one of the engineers of the LHC reconstruction team. Why is today's milestone so important?
Une étape importante parce qu'aujourd'hui on va descendre le dernier aimant qu'on voit ici derrière moi. Le dernier aimant dipolaire.
Today's milestone is an important one because today we are lowering the last dipole to transfer it to sector 3-4, closing this sector up.
Et il faut savoir que lors de cet incident qui est survenu...
Following the incident on September 19th, we had to extract 53 magnets in total, out of which 39 were dipoles exactly like this one, get them to the surface and repair them.
Sur ces 39 aimants, il y en a 30 qui ont dû être substitués par des aimants de réserve.
We replaced 30 dipoles with spares and we managed to recover 9 dipoles, repair them and put them back into the tunnel.
In situ dans le tunnel. Donc cet aimant va...
The dipole magnet we're lowering today will be transported through 3 of the 8 sectors in the LHC machine. It will be put into place during the night and tomorrow it will be aligned by the survey team. In the next few weeks it will be interconnected to the magnets already in place in the sector.
C'est également une étape importante parce que...
This milestone is particularly important because once this last dipole is in place, we will be able to inject superfluid helium into the sector.
On va pouvoir remettre l'hélium à l'intérieur de ces secteurs. Les conditions de sécurité nous imposent...
For safety reasons, we cannot have helium in the magnet's cold mass during transport. So once this magnet is in place, we will be able to inject helium and perform tests to make sure the sector is ready to restart the machine.
La série de tests qui nous assure que les secteurs sont sains pour la remise en route de la machine. Les étapes suivantes, c'est la connexion.
The next steps are interconnections, electrical tests, pressure tests and powering tests to make sure the machine is healthy and able to function.
Assurer que la machine est bien saine pour pouvoir fonctionner. Et ce qu'il faut savoir, c'est qu'entre les différents techniciens,
If you add up the number of technicians working on these operations, together with the teams working on quality assurance, coordination work and the consolidation of the machine in other sectors to avoid a similar incident in the future, all in all, we've had 200 people working in the tunnel since the incident.
Consolider la machine dans les autres secteurs pour éviter un nouvel incident de ce type.
And you can see the big crane behind me, ready to go and grab the big magnet. The lowering operations are starting in a moment. We've taken the opportunity to ask some details about it to the woman in charge of this far from trivial transport operation, Caterina Bertone.
The magnet that you see on my back is the very last that we are bringing down into the tunnel after the incident of 19th of September 2008. This concludes a long process in which we have removed 39 dipoles and 14 short sections. The very last magnet has the same difficulties to be transported than the previous one. It weighs 33 tons and it's 15 meters long and it's extremely fragile. It can look strange that a piece that is 33 ton weight is so fragile, but it's full of high technology material that is used to do its job, to produce a good magnetic field. The transport and installation phase is a quite complicated one because there is just one shaft from which all the LHC magnets are lower down, and in the first installation there have been 2,000 magnets to be lower down. Most of all, you have to know that the LHC tunnel is like a corridor. It's like a one-way road, so one can go forward or backwards, but you cannot go backward if you have someone on the back of you. During the installation phase, we have installed with the rhythm up to 30 to 35 magnets per week. That means 6 magnets per day. That means that we have made small trains of 6 magnets, one behind the other, and they were obliged to follow a special path. That means very complex logistics in the underground tunnel. The traveling into the tunnel can take 1 hour per each sector. That means that if you want to reach the more far position in the LHC, you have to travel more or less 8 hours. It is quite very long and difficult to organize.
And while the last dipole is on its way towards sector 3-4 of the LHC tunnel, I invite you to follow our next update on this space early next May.